We are nearly there. It is question 19. We are use special triangles. Now, what is this 45, 45, 90? This is a special triangle where it's a right angle triangle, and then you have other two angles as 45 degrees, and then 90 degrees. Here you can find the sides without any help of trigonometry, and easily you can use some rules to find the sides. Let me tell you. For 45, 45, 90, the hypotenuse is always equal to square root 2 times the length of any of the side. This is the hypotenuse, right? The other two sides must be equal because it's like an isosceles triangle. Because these two angles are equal, these bases or the legs of the triangle must be equal. Now, if you know any one length, say this is 3, then the hypotenuse is square root 2 times L. That's it. Whereas there's one more special type of triangle where this can be something like this. It is, okay, now this one can be taken as 30, 60 degrees up above and 90. This is also a special thing. Why? Because it is in the ratio of 1 is to 2 is to 3, right? Now here, the hypotenuse is given as twice the smallest side. Now, which is hypotenuse? This one. Over here, this is hypotenuse. These two are legs. But here, hypotenuse, but these two are not same because the angles are different. The lengths also vary. So imagine this is the angle we are considering. The opposite side will be formed because of this angle. So now this is the smallest angle, so this will be the smallest side S. Now this 60 degrees is the leg, one of the legs, shorter length and the longer length. I'll take it as L and the hypotenuse. So here hypotenuse is twice the shortest side. And what about this one? The leg is equal to the square root 3 times the shortest side. These are the formulas you must remember. These two are for 30, 60, 90 degrees triangles, whereas this one is for 45, 45, 90. We just put a dash in between. So that is these are the two formulas. Now with these formulas, you can solve all the problems in this particular topic. But the first one has various ways to solve. So here they have given you find the coordinate x, which is all in the first quadrant. Y and z value is given. So if you don't like any of the formulas, only for this particular problem, let's start plotting it out. Y is minus 1. Okay, there's minus 1 and 2 somewhere over here. That's the first point, Y. Then Z is 6 somewhere over here and 2. They are at the same thing. Okay, that is Z. And we need to find the coordinate of X in the quadrant 1. It must be over here with the 45, 45, 90 degrees. So let's just draw this line here. So if it has to be 45, 45, 90. Now, this is, imagine this is one leg. So what can I do? Now, did they tell anything about the biggest length or anything? No, they have not told anything about that. So what you can do is the same distance. What is that distance from here to here? It's minus 1 to 6, right? I can take the same distance up over here, or I have to take up over here. Why? Because I can't take down. It will be in the second quadrant. They have clearly mentioned it must be in the first quadrant. So here there must be a point. How much? Can you see this? This distance is total 7. So I have to add over here as well. This must be 7. This and this must be 7. So we know this point over here is how much? At 2, right? 2 plus 7 will be 9. So this is at 9. The y coordinate is at 9. What is the x coordinate? It is 6 because it has to be in the first quadrant. So it's 6, 9. And that would be the 45, 45, 90. Now it's not accurate because it's not to the scale. But you can easily tell, since it had to be in the first quadrant, it has to be above. From z, it must go up. So x value is 6 and add the same distance, 7 to that, that will be 9. So 6 and 9, you can see the answer is 6 and 9. You don't need to do anything else. I'll just repeat this again. You only have this one, the one side. So let me just take all that off. Okay. You only know this much from the given coordinates, right? This is minus 1, 2, and this is 6, 2. Now they have told the point x must be in the quadrant 1. So it must be over here. It can't go down because we know one leg length is how much? 7. So it must be 7. It has to go up. So this must be 7 itself. So from the z point, we know the value of the x coordinate is 6. But what is the y value? It has to be 2 plus 7 because it's going up. This is 2. 7 must be added. It will be 9. 9 over here because that 2 plus 7 is 9. So it's 6 comma 9. Then we can just join them and that will be the 45, 45, 90. So basically in 45, 45, 90, this base and one more base must be equal. Now in my drawing it's not accurate, but it must be equal. So if this is 7, this is also 7. That's why we get 6, 9. Now what about this one? Here also you can do the same thing. They have told the quadrant 3 this time. We have to focus on the quadrant 3. But only for the point E, but we can plot the other points. What is F? Minus 3, 1, 2, 3, and minus 4 somewhere over here. G is minus 3 and 2. Okay, this is minus 4. So let me take it over here too. Now we need one more point, E, which is somewhere in the quadrant 3. But they have also mentioned the longer length L is FG. So let's just count it. We don't need to find the distance between it by distance formula or anything. We know this point. I'll consider this one was FG. Yeah, this was F. Minus 3 comma minus 4. And this is G at minus 3 comma 2. And what's the distance from minus 4 to over here? This is 4 plus 2. It's 6. The distance is given as 6, isn't it? So L is 6. Now from this we know the formula for S. Or we can find the hypotenuse as well. But first, if we recall, L is equal to square root 3S for 30, 60, 90. So now what I can do is 6 divided by square root 3 will be S. Now you can just put this in the calculator and you can find the answer. So here we have 6 square root 3. That's it. That'll be S. That is 2 root 3, or I'll take it as 3.46 just for understanding. I'll take it as 3.546. S is 3.5 approximately, okay? So now we got this S as 3.5. Now they have clearly mentioned E must be in the quadrant 3. So we can't take from year to year. It must be here, guys. So F is there. If you consider this length of 3.5, so that is minus 3, right? If you go backside, because it must be in quadrant 3, we can't go here. It will be in the positive quadrant. I mean, the fourth quadrant. So let's go back. Minus 4, minus 5, minus 6, minus 6.5 here. The X value, that would be E. And then what is the Y value? It'll be minus 4 itself. So that's it. That'll be the point. And then that's the hypotenuse. This is the shorter length. Now look over here. My scales are not appropriate. So this is around 3.5, 3.46 accurately. And I don't need to find the hypotenuse length. All I need is just this S value. And then we are done. So from length, we can easily find the S, the shorter side, which is 3.5. And now we can just trace back from this X value to minus 6.5. That will be the approximate answer. So you can see here, now minus 3 minus, this is about 3.5, will give you minus 6.5. That's, and comma minus 4. That is how we do it. You don't need to do all this. It's electronic part. No need of writing anything. Directly jump to the coordinates. Now we have problems. Now these are pretty simple if the figure and everything is given over here. They have told over here Melody is in charge of building a ramp for a loading dock. According to the plan, the ramp makes 30 degrees angle. This is given as 30. You can see this is 90, so this will be 60 degrees. We have a special triangle here, special right triangle. And then the plan also states that ST, can you see this ST base is 4 feet longer than RS. Okay, 4 feet longer than RS. Now let me take this RS as X. So ST is X plus 4. Whatever is this, sorry, RS is not hypotenuse. It can't be longer than hypotenuse. My bad. RS is this X, okay? So this will be X plus 4 no matter what. We need to find the lengths. Now here, what is the relationship? We have this RS to be the shorter side and this one is the longer side. This is 30, 60, 90. We know from the special triangle, L will be equal to square root 3S. Now just substitute L and S. So L will be X plus 4, that is equal to square root 3X. Now how could we solve this? All you need to do is the square root 3, if you put in the calculator, you will get a value. It'll be more than 1 anyways. So what I'll do is I'll take this x to the other side. It'll be 4 is equal to square root 3x minus x. And now here, let's use calculator. So square root 3 minus, what is this? Nothing, means it's 1, right? So square root 3 minus 1 will be 0.73. So this answer over here will be 4 is equal to 0.73, nearest 1000. So 732x. Now take this to the other side. That will be division. So it'll be 4 divided by this answer, that is 5.464. So that is the dimension of x. X will be equal to 5.464. How? Divide both the sides by this value. So this cancels over here, and over here we get 5.43464. It's not over. Let's see, what do we have to find? Find the three sides. Okay, I have just found the x value, that is the shortest side. RS is found, that is 5.464. Now what about the other sides? I can easily find TS. How? Or ST, because that is just x, whatever this is there, add 4 to it. It will be 9.464. And what about RT? The hypotenuse over here is always given as 2 times S, isn't it? So this is S. I just have to multiply it by 2. So whatever the answer, just multiply it by 2. Here you go. The answer is 10.928. So these are the three sides. So you can see here, it's 10.928, 9.464, and 5.464. I hope this is clear. You have to use the rule, this one. Length is equal to square root S. That's firstly used. Then we find the x value. Because x is the RS distance, right? Then from that shorter distance, we can find the hypotenuse. That's how we do it. You can see the detailed steps as well. And what do we have over here? We have an interesting problem. Let's do this one. Lai Ling is making a quilt. She starts with two small squares of material and cuts them along the diagonal. Okay, you can see here, these are the two small squares, right? She has cut them like this on the diagonals. So she got two triangles over here. Then she arranges the four resulting triangles to make a larger square quilt. You can see this is a bigger square now. She wants the large quilt to have a block of area of 36 square inches. This is a square and the area is given as 36 square inches. Okay, inches square. What is the side? Just take the square root of this. It will be 6. Okay, the side will be 6. So this is 6, 6, 6, and 6. So what side lengths should Lai Ling use for the two small? Okay, we need to find these sides now. Now remember guys, this 6 is not the side, okay? That doesn't make sense because this will be the same area. It's not. So here if you have 6, what is that 6? This diagonal, because see the diagonal is cut. This will be over there. Then these are the inner sides, isn't it? So the diagonal is basically 6 and 6. How do we find these? Now since it's a square, this is 45 degrees, and 90 degrees. It is as a 45, 45, 90. And over here we have only a single formula for 45, 45, 90. That's hypotenuse is given as square root times 2 times L. And we know the hypotenuse is 6, right? So how do we find the length? Just divide this. 6 divided by square root 2 is L. You can put that in the calculator and find the exact value. Here we have 6 divided by square root. So let me just write 6 divided by square root 2. And the answer is 3 root 2 of 4.24. So 3 root 2 is taken. The lengths of the smaller squares must be, oh yeah, even it's written as 4.2 or 3 root 2 inches. And they have asked us a part B over here. Explain any assumptions that you make to answer part A. Now what assumptions? When we cut, there is no wastage, or it must be accurately cut, I believe. Let's just look over here. The assumption is that cuts are made with accuracy. Also, the sieving seams, small rectangle does not. Okay, it's basically you're not using any extra material. It's exactly or very accurately we're using only these dimensions. That's what. But usually when you cut, there is some wastage and you won't get accuracy, And when you sieve them together, like when you stitch them up, there'll be wastage of area as well. Another problem, we have to find the perimeter of this quadrilateral and round to the nearest tenth. Now you might be thinking why there is a quadrilateral. It's about triangles, but you can see there are two triangles as well. This length is given. Perimeter is just all the sides. Add up all the sides. AD plus AB plus BC plus CD. That will be the perimeter. AD is given as 27. Now, what about the other sides? We know this is equal. So let's only focus on one of the triangle. This angle is given as 135. How much is this? 90. So the remaining part is 45. If this is 45, this is 90, this has to be 45 degrees. Now, whatever is this dimension will be equal. Sorry, this is the hypotenuse. Whatever this and this are equal. If you have 7 here, this is 7. They are equal, isn't it? So we know this is 7, this is 7. So what is remaining in between? For BC, it will be 27 minus 7 and 7. That's 14. That will be, it'll be 14. Sorry, 7, it'll be 13 over here. Okay, this is 13. So 27 minus 14. So plus, AB is unknown. I'll find it in a while, but I know BC is 13 here. But what is AB now? What is the rule for 45, 45, 90? It's hypotenuse is given as square root 2 times L. What is L? L is 7. So square root 2 times 7. That's the answer. And over here also, plus square root 2 times 7. That will be the perimeter. You can just put in the calculator now. So all you need to do is 27 plus square root 2 times 7. You can multiply this by 2 because it's repeated, or I'll just write it out directly. And over here again we have to repeat it. Go next and now multiply it by 7. The answer is 59.8, nearest tenth, right? 59.8 is the answer. So that will be the answer. That's how we can easily solve this one. Now, why are some right triangles considered special? Because you can easily find the sides without complex calculation. Let's just check the answer over here. Once you identify the right angle is special, either it's 30, 60 or 45 degrees, you can solve them without using a calculator. See, if you want the exact value, you need a calculator, but still you can write it as root 3 times 5 or something like that, right? So without calculator, you can just use the formulas and write it out. Now here they have given a figure. Carmen and Audrey wants to find the value x in the triangle shown. Okay, who is correct? Explain your reasoning. Let's try this out. Here, first of all, let us just solve it without looking at these. What do we know? This is an equilateral triangle. All angles are equal, so it's 60, 60, 60. But then what do we have is, we have 90 here. This is 60 because if all the angles are equal, it has to be 60, 60, 60. Only then it's 180 degrees. Half of 60 is 30. So it's 30, 60, 90. Now then, what formulas work over here? I'll write both the formulas. One is the hypotenuse is equal to 2 times the shorter distance. And one more is L is equal to square root 3 times S. Now this is hypotenuse. This one is the longer distance, which is x, and this is the shortest. Why? Because opposite to the 30 degrees is the shortest distance. Now, what can we find out? We know h, and we know x is L. So, do we have anything? No, we don't have anything for that. But we know h value, so we can find s value. What am I thinking? I was thinking over here. Easily we can find s value. So, h is equal to 2 times s. H is 6 is equal to 2s. So 3, divide both the sides by 2, you get 3 as s. Now we need to find x, isn't it? What is x value? X is basically L. So x will be equal to square root 3 times, what is this? 3. So it will be 3 square root 3. Who has done it correctly? Carmen has done it correctly. This is wrong. So that's how we can tell. Carmen is right. When we just solved it up, we got the answer. I think so over here, what the mistake she has done is she has used square root 2. That is in the 45, 45, 90 degrees. Not, see, this is the accurate formula. Now 6 by 2 is basically 3. We have found the short distance, right? See, we directly found it 3. They have written it as 6 by 2. It's up to you. You can write it as 3 square root 3 directly, and this is the correct one. The ratio of the measure of angles of a triangle is 1 is to 2 is to 3. When they tell you 1 is to 2 is to 3, what is the answer? Which type of triangle it is? 30, 60, 90. Okay, the length of the shortest side is 8. Okay, S is given as 8. What is the perimeter of the triangle? Okay, they want us to know the perimeter. Now imagine this is 60, this is 90, this is 30. So S, that is equal to 8, is given. We don't know any other distances, sides I mean. We need to find all the sides to the nearest tenth, and then we need to add them all up to find the perimeter. So the formulas are H is 2 times S. So H is 2 times 8, that is equal to 16. So the hypotenuse is 16 here. What about L? L is equal to square root 3 times S. So L is 8 square root 3. 8 square root 3, right? Now we will just use a calculator and add them all up. So here we have 8 plus 16 plus 8 square root 3, and the answer is 37.8, 37.9, because nearest tenth would be 37.9. Okay, this is 37.9. That's the correct answer. 16 and then 8 square root 3. You don't need to find it over here. You can directly put everything in calculator and get the answers. The last one over here, we need to draw a rectangle. Let's draw a rectangle first. That has diagonal. Okay, imagine this diagonal is twice as long as its width. Width, this will be the length. The diagonal, I'll take this as hypotenuse. H is 2 times width. Okay. Then write an equation to find the length of the rectangle. So now this is, basically 45, this is 90 degree. It is, they have told it's 2 times width. We can directly tell this is 30, 60, 90, and the length is equal to square root 3 times W. We know the formula, right? From 30, 60, 90, that's the answer. Okay, they are expecting us to do in Pythagoras theorem. Let's just do it. They're basically asking us to prove the formula. That's the thing, okay? You can see over here, they're asking us basically, what is this? Like, prove it, not use the formula directly. So L is unknown, okay? So I need to find this one. So I'll consider this as X. What does the Pythagoras theorem say? It's 2 over here. 2w the whole square will be equal to sum of the other two squares, w squared plus x squared, which is unknown. So let's solve it up. 2 squared is 4, w squared is equal to w squared plus x squared. I'll take this w squared to the other side. It will be 4w squared minus w squared equals x squared. It is 3 w squared equals x squared. Take square root on both the sides. This is going to be square root 3, and w square and square root cancels. The square, this cancels with this, and so you allow only w and x. So the dimension over here we can find as square root 3w. Okay, so we can directly tell this from the the rule of 30, 60, 90. This is the other length, but from the derivation also we can get the same length. But since the electronic part, you can just tell the answer, choose the correct answer directly if you know the formula. So that's how we solve this problem, and that's the end of this topic. A bit lengthy. Just remember the formulas for the two special type of triangles, and then you can solve them up easily.